Welcome everybody. We are now on lesson 6-2, negative exponents. And let me tell you, this is something that really trips kids up. So really pay attention, take some good notes on this one. This is tricky. The last one, hopefully, you thought wasn't too bad, but this one's tricky. All right, consider the expression 4/3 divided by 4/8. Well, we know our rule. When you're dividing powers with the same base, you subtract the exponents. You might be tempted to subtract 8 minus 3, but remember, that's not the rule. The rule is you subtract the exponent of the numerator, I'll just use num, minus the exponent of the denominator every time. Denom. Okay? So that means you end up with 4 to the 3 minus 8 power, and 3 minus 8 is negative 5. So negative exponents happen when you're dividing powers with the same base. But what does this negative 5 mean? I will tell you it means nothing like what negative numbers mean. So let's write that down. Negative exponents have nothing to do with negative numbers. They don't act like negative numbers. They don't mean what negative numbers mean. So negative numbers mean you owe something or you have a loss. That is not what negative exponents mean at all. They're completely different, and this is why they're tricky. We can figure out what this negative exponents means by using our expanded form. So 4 to the 3rd power is 3 factors of 4. 4 to the 8th power is 1, 2, 3, 4, 5, 6, 7, 8 factors of 4. And then we cancel what cancels. And because we had more factors of 4 in the denominator, our 4 to the 5th power ends up underneath the 1 in the denominator. So, since we got the math doing the same thing, 4 to the negative 5th power has to be the same thing as 1 over 4 to the 5th power. So these are the same thing. And when we are simplifying exponential expressions, this is the one I want. I do not want this guy. Let's erase this real quick. Just really quick. For that guy. Okay, so here's our newest rule. Write this in your book, please. So the rule says that a negative exponent means the power is in the wrong place. Sorry, gotta mess with my pen. Move it to the other side of the division bar and make the exponent positive. So if I come across a power that's raised to a negative exponent, realize this is in the numerator, right? We don't usually draw over 1, but it's there all the time. I can easily make any power into a fraction by putting it over 1, right? So this 4 to the negative 5th power is in the numerator. We need to move it to the other side, which is the denominator, and make the exponent positive. And the reason I say move it to the other side instead of drop it into the denominator is because sometimes it starts out in the denominator. Negative exponents don't only have to occur in the numerator. So if you have a negative exponent in the denominator, we're going to follow these same rules. Move it to the other side of the division bar. So we're going to move 3 to the 4th power into the numerator, and we're going to make the exponent positive. So 2 divided by 3 to the negative 4th power is the same thing as 2 times 3 to the 4th power. Got it? Let's try something else. Okay, so I'd actually like you to pause here and give this a try, fill this out, and then when you start, I'll show you what to do. So it says rewrite the numerator and denominator in expanded form and simplify. All right, so x cubed would be 3 factors of x, and the denominator, x to the 5th power, would be 1, 2, 3, 4, 5 factors of x, right? So then it says simplify. Oh, and simplify. So we need to simplify this. Let's do some canceling. Magenta's so good for canceling, so dramatic. So x divided by x is 1, x divided by x is 1, x divided by x is 1. And then we gather up what we have left. And we have in the numerator 1 times 1 times 1, which is 1. And in the denominator 1 times 1 times 1 times x, which is x squared. Okay, so when I use expanded form, I get 1 over x squared. Now it says simplify the expression by dividing. So we're using our rules now. So our rules say when we divide powers with the same base, we subtract the exponent of the numerator minus the exponent of the denominator. And I could even write that as 3 plus a negative 5 because I don't like subtraction. But either way, you're going to get x to the negative 2 power. Compare your results. So on one of them, I have a positive exponent, but it's in the denominator. And on the other one, I have a negative exponent, but it is in the numerator. These mean the same thing. To get rid of a negative exponent, and you're going to have to get rid of negative exponents, an expression is not considered fully simplified if it has any negative exponents. So you can't stop here. You have to change x to the negative 2 power into 1 over x squared to complete a simplification problem. All right, when an exponent has a negative value, it usually means to divide 1 by the base of that number, that number of times. So they mean you're dividing instead of multiplying. But this is kind of misleading because sometimes our negative exponent starts in the denominator, and then instead of dividing, you're multiplying. So let's look at these two examples right here. So the way we are getting our power to the other side of the division bar is we are taking the reciprocal. So the reciprocal of a number is the multiplicative inverse. I don't know if that's helping you. Most people think of reciprocal as the flip of the fraction. Like when we keep change flip, when we're dividing fractions, we're taking the reciprocal of the second fraction. That's the flip. But be careful because here we're going to take the reciprocal of the whole thing. But sometimes you have problems where some of the powers are negative and some are positive. You're not taking the reciprocal of the whole fraction, just that one power. Okay, so for this one we have x to the fourth divided by x squared. So my rules say subtract the exponents, and I get x to the second power, right? Here I have x squared divided by x to the fourth, and the rules say subtract the exponents, always exponent of the numerator minus exponent of the denominator, and I get x to the negative 2 power. So these are reciprocals of each other because these are reciprocals of each other, right? X to the fourth on top, x squared on the bottom. We flip it, we get x squared on the top and x to the fourth on the bottom. So if you have the same power and one's negative and one's positive, these are reciprocals of each other. I could simplify this one to be 1 over x squared, and then it's more obvious to see that x squared and 1 over x squared are reciprocals. But it is true, even if I leave it x to the negative 2 power, they are reciprocals. Okay, write 6 to the negative 2 as an equivalent expression without a negative exponent. This is what we're going to be doing over and over again. Every time you have a negative exponent, it is your job to get rid of that negative exponent. And the way you're going to do it is you are going to move that whole power to the other side of the division bar, in this case, the denominator, and the exponent goes from negative to a positive. All right, so for a, we have a to the negative 4th power. That negative on the exponent tells me These 4 factors of a don't belong in the numerator. Let us put them in the denominator, right? Remember, this is a to the negative 4 over 1, so we're going to make it 1 over a to the 4. This is 8 to the negative 3 over 1, so we are going to make it 1 over 8 to the positive 3. Once you take the reciprocal, the exponent becomes positive. This is 1 over 3 to the negative 2 power. We're going to take the reciprocal, and we get 3 squared over 1, which is the same thing as just 3 squared. Is it sinking in? Is it getting any easier? Let's try more problems. Okay. So you can see they're getting more complicated, but you got this. So when we're simplifying these expressions, the first thing we're going to do is use our rules. Y to the 4th divided by y to the 8th is to the same as y to the 4 minus 8. We're subtracting the exponents, which gives me y to the negative 4th power. You may not leave it this way. If you leave it this way on the next quiz, you will lose points. You need to keep going until you have a positive exponent. For every power, the exponent has to be positive. So for A, the answer is 1 over y to the 4th. For B, we have 10 to the 12th divided by 10 to the 15th. So I subtract the exponent to the numerator, and this time I'm going to write it in my preferred method, minus the exponent to the denominator. And I get 10 to the negative 3rd power. But I'm not done. I'm going to keep going. And I'm going to rewrite this as 1 over 10 to the positive 3rd power. So in order to get rid of those negative exponents, you need to move it to the other side of the division bar, take the reciprocal, and make the exponent a positive number. So let's look at C. So C, we have a lot of powers in there, and that makes it tricky. So we're going to need to deal with these separately because I have 2 sets of powers with the same base. I have the 4s. Those are powers with the same base. And, come on, and I have the 5s. Powers with the same base. I can divide these because they have the same base. I can't divide these. They don't really have anything to do with each other while we are simplifying. Oh, come on. Don't like this bad. Okay, so 4 to the negative 2 power divided by 4 to the 3 power. I am going to subtract the exponents. So I get 4 to the negative 2. I subtract the exponent to the numerator minus the exponent to the denominator. And you notice I didn't use minus, I used plus to negative 3. That's actually going to make my life easier here. And then that's going to be multiplied by 5, and I'm going to subtract these exponents because I'm dividing. So I'm going to have 5 to the 7 minus a negative 2 power. Oh, so many people forget this negative sign. They feel like, well, I already have a minus sign. Yeah, you need them both or you're doing the wrong math. So negative 2 plus negative 3 is going to give me 4 to the negative 5th power. And I know that 7 minus a negative 2 is the same thing as 7 plus 2. So I have times 5 to the 9th power, 7 plus 2. Okay, so I've done the division, but I'm not done with the problem because I can't have a negative exponent in my answer. 5 to the 9th, that is a positive exponent. So I'm going to leave it right where it is. I don't do anything with that power. Only the power that has the negative exponent is going to move. And it is going to move into the denominator, and I'm going to make the exponent positive. Whoa, did that problem just blow your little mind? I know, right? These get tricky in a hurry. Let's do some more practice. Okay. X to the negative 7. I can just take the reciprocal. So the x to the 7th power moves into the denominator, and it's not negative anymore. It's positive because it is where it belongs. So this is 6. Problem number 7. 5 to the 6th power divided by 5 to the 9th power. So I'm going to subtract the exponents, or in my case, add a negative. And I will get 5 to the negative 3 power. And I'm not going to leave that negative exponent. I'm going to say 5 to the negative 3 power is the same as 1 over 5 to the third power. And problem number 8. So again, I've got two pairs here. I could even write this as x to the 5th divided by x to the negative 4th times y to the negative 2 divided by y to the 4th. Right? We know if I multiply these fractions together, I'd get right back to here. But this way I can see I'm only dividing powers with the same base. So here I'm going to have x to the 5th, exponent to the numerator, minus negative 4, minus the exponent to the denominator. Here I'm going to have y to the negative 2, exponent of the numerator, minus 4, exponent to the denominator, but I wrote it as plus a negative 4. And this I'm going to rewrite as 5 plus 4. So I get x to the 9th power times y to the negative 6th power. I'm not done because one of my exponents is negative. The exponent, the power that has a positive exponent stays where it is. And remember, both of these factors are in the numerator. The exponent with the negative power moves to the denominator, and its exponent becomes positive. How about now? Is it clear now, or would you like just a couple more examples? Just a couple more. The more you do it, the better you get. So 9 to the negative 10th power, we're just going to flip that over. Hopefully you're getting pretty good at these. Yeah? All right, number 10, so that's number 9. Number 10, we have k to the negative 5th power over k squared. So I can rewrite that as k to the negative 5th power minus 2, or I'm going to write it plus a negative 2. Same thing. You know it's the same. And I get k to the negative 7th power. And if I have a negative exponent, I'm always going to rewrite it by moving that whole power and its exponent to the other side of the division bar and making the exponent positive. Number 11. I have 3 to the 3rd power times 3 to the negative 6th power. Well, now I am multiplying powers with the same base, and the rule says we add those exponents. 3 plus negative 6 is negative 3. And then here at the very end is when I say, oh, negative exponent, you're in the wrong place. You need to be in the denominator, and then the exponent is positive. Last one. I hope it's sunk in. We got 2 to the 4th power times 10 to the negative 6th power divided by 2 to the 2nd power times 10 to the negative 2nd power. So let's divide these first. So 2 to the 4 minus 2 power, and then 10 to the negative 6 minus a negative 2. Do you see why we reviewed our integers? You were thinking, when am I ever going to use this? Boom, you're using it right now. Okay, so this is going to be 2 to the 4 plus negative 2 is 2. That has a positive exponent. But the 10 is going to be to the negative 6 plus 2, which is the negative 4th power. So we got to take this one more step. The positive exponent stays where it is in the numerator. The negative exponent sinks into the denominator, and its exponent becomes positive. Any questions? Oh, you can't ask questions. All right, well then I hope you enjoyed the video, and I'll see you tomorrow.